This video is on epoxidation. Epoxidation is the term used when we convert an alkene into an epoxide. It is by far the best way to make epoxides, and it is analogous to the carbene reaction, except instead of having a carbon, we have an oxygen. So what do we need? We need an oxygen with its lone pair, along with a positive charge. Oof, that's a hard ask. Probably just a good leaving group. Ergo, we get percarboxylic acids. They are like carboxylic acids, but with an extra oxygen. If you put one near an alkene, this is the mechanism that occurs, and it leaves us with a carboxylic acid and an epoxide. And that's it. You've done an epoxidation. So, for example, if we take cyclopentene and react it with this percarboxylic acid, we will get this epoxide. Now you have a go. What would the product of this reaction be? You may pause now. And here's the answer. Note the stereochemistry, just like with carbenes, as we are adding the oxygen from only one phase, it must have stereochemistry. Another thing to note, this reagent here, this specific chemical, is referred to as mCPBA. Means m-chloroperbenzoic acid. Don't worry about that first part, but remember mCPBA. Why? Because you will see instances like this. What is the product of the following reaction? Here we go. You must recognize mCPBA as being the epoxidizing agent. And voila, you know what the product should be. This is the answer. If you ever get asked how to make an epoxide, the answer tends to be mCPBA, in dichloromethane in this case. However, it does not have to be mCPBA, i.e. what is the product of this reaction? You may pause now. And this is the answer. How do we know? Because the carboxylic acids seem to have an extra oxygen, making a percarboxylic acid.